Okay, so let's see this problem. It says Marcel is designing an outdoor stage. When complete, the stage will be represented by the polygon A, B, C, D. So what we need to do, they want to know what the distance is from here to there. Couple of ways to do this. I think the easiest way is to use the Pythagorean theorem and just draw a right triangle that would extend. I'll put it in a different color. I mean, you could do this using a couple different methods, but if we just drew this right triangle, came right down there, we'd see that this distance is 1, 2, 3, 4, 5, 6 units. But we also have to realize that each unit is 5 feet. So if I'm going to redraw my triangle, which is really poor triangle, I'm going to do it anyway. That's going to be 30. And this right here, going all the way down right here, well, that's 7 plus another 6 is 13, but 5 units, so it's 65. But we got a right triangle, so now we can just apply the Pythagorean theorem. Here's a squared plus b squared equals c squared. And again, there's other ways to do it. We could have taken these points and figured this out a different way, but I like this way. So a squared, so we have 900, because 30 times 30 is 900, plus 65 times 65 is 4,225, equals c squared. And those added together equal 5,125. 5,125 equals c squared. If we take the square root of both sides, then that'll give us 71.59, and it says to round to the nearest foot, so our answer would be 72 feet from here to there. Well, hopefully this one isn't too complicated. Miss Davis drew a box and whisker plot to display the data about the number of hours her piano students practiced last month, as shown below, right here. What whole number best represents the median number of hours her students practiced playing the piano last month? Well, in the box and whiskers plot gives us this median right here. So we should have easily come up with 35 for this answer. Okay, so number 3, an architect is using an isosceles triangle. So we got to remember isosceles triangle, two sides are going to be the same. Isosceles. In the diagram below, all line segments represent steel beams needed to build this section of the bridge. Triangle DEC is similar to CAB. So I'm going to put that in a different color. CAB, which tells us that this piece here is similar to this piece here. So this piece here is also similar to this piece here. So we have 5 over 4 is similar to x over 2. So now all we have to do is cross multiply. So we just do that and we get 10 equals, we do this, 4x, divide both sides by 4, and we get x equals 2.5. So that's what you should have for this one, 2.5. Okay, so this one a little tricky, but it says formula for the area of a triangle is shown below, right here. Which of the following is the solution for h? So we want h to be all by itself. First thing we want to do is multiply everything by 2. So if we have this area equals 1/2 base times height, we multiply everything by 2. So then that'll give me 2a equals, these cancel out, b over h. We're trying to get h by itself, so we're going to divide everything by b. So my resulting answer will be 2a over b equals h. Okay, so in this problem you have to use some of your linear thoughts, how to look at functions. Notice in this problem that there's a 6-foot tall cylinder, and you can read through it, but as this goes down by, it goes from 1.5 to 0.5, so that's down by 1, and this side goes down by 16, and then here it goes down by 2, or up by 2, sorry, up by 2, and here up by 32. So it is a linear function. For every 1, it goes up 16. So to go from 2.25 inches of rain, so to reduce it from here down 1/4 of an inch, that's 1/4 of this. Right? So it's going to go down to, we're going to reduce that by 4. So that goes down to 36 inches. Okay, so let's see what they're saying. The illustration is made up of AD, BE, and CF. All 3 segments intersect at point H. AD is perpendicular to BE. So AD is perpendicular to BE. So that simply tells us that these are right angles. The measure of angle FHA, so let's put that in a different color. FHA, this angle here, is 65. And what is the measure of BHC? BHC. So we're going to look for that angle. Well, we know that this angle here is also going to be 65. And we know that this is a 90-degree angle, so this plus this has to equal 90. So 65 plus something equals 90, and that is 25.